All right, related rates. Let's talk about the word rate. Okay, we should be getting a little bit used to the word rate. What are some examples of some rates?
Time.
Time's not a rate.
Second.
Miles per hour would be a rate.
Seconds.
Meters per second would be a rate. Feet per hour. Any of those. What is it that you're describing on those rates?
Distance over time.
All right. Well, what is that?
Speed.
It could be speed. What else could it be?
The rate of change.
If I've got a distance over time, what is it we're talking about? We're either talking about speed or we're talking about
Acceleration.
no, not acceleration, velocity. Okay, a distance over time is we're talking about velocity or we're talking about speed. Okay, how are those two related again?
Speed is the absolute value of velocity.
Excellent, Chris. Speed is the absolute value of velocity. That's why speed and velocity have the same units. Okay, it's always a distance over time. Okay. Well, today we're talking about related rates. Okay, we can have different types of rates. It doesn't have to be a distance over a time, but most of the time it will be. But it doesn't have to be in terms of something moving. Okay. Today we're getting into, it just has to be what?
It just has to have that curve.
Right, it has to be a change in something over a change in time when we're talking about a rate. So the rates we're looking at today is going to be a change in something over the change in time. Okay, and how different types of rates are related to each other. Okay, that's what it is we're looking at today. Jeff? Question?
No.
Good. So we're going to look at just a general problem to start with, and then we'll get into some more application problems after we get the first one done. So we're going to look at number 4 to begin with on page 154. Okay, we're just going to look at part 1 or part A. On number 4, they're giving me the function x squared plus y squared equals 25. Well, I guess that's not really a function, is it? Why is that not a function? What is x squared plus y squared equals 25? Does anybody remember what that thing is? It's an equation, but what's an equation of?
Circle.
It's an equation of a circle, so why is that not a function?
Because it's circles, and it doesn't make a line.
Why are circles not functions?
Because
There can be more than one y value for
There's
x
more than
side.
one y value for your x's values. It doesn't pass the what?
Vertical line.
Vertical line test, so that's why it's not a function. So here's my equation, x squared plus y squared equals 25. It says we want to find dy dx, dy dt, sorry. dy dt when x is 3, y is 4, and dx dt is 8. Okay? Now, when we have taken derivatives in the past, what's usually on the bottom? Dx. Okay, we always taken it with respect to x. But if we're talking about rates, a rate is always something over a change in time. So instead of taking it with respect to x, we're going to take it with respect to t. Okay, and that's the reason why related rates follows implicit differentiation. Because every time I take the derivative of an x value, I'm going to have to write down what? Dx, dt, and every time I take the derivative of a y value, I've got to write down dy dt. Okay? Or anytime I take the derivative of any type of variable, it's got to be d of the variable over dt. Okay? That's why it follows implicit differentiation, because that's really what we're doing here. Okay, so dy dt is what we're trying to find, and this is all the information they give me. Now, let's talk about what dy dt and dx dt represent. What does dx dt represent? Right, it's the derivative of x with respect to t, but what is dx dt? What is it? Yeah, you're not thinking the way I want you to think, though. What is it we're working on today?
Related rate.
We're working on related rates. So what is dx dt?
Rate of
The rate of
The tangent line.
x. The change of x.
change of x with respect to
T time.
the change in time. That's what dx dt is. It's the rate of change of x with respect to time. Okay? So dy dt is what?
The change
Rate of
y.
change with y with respect to
Rate of change.
time. That is correct. Okay, so that's what we're looking at there. That's what those things represent. Okay, so they're telling me x is 3, they're telling me y is 4, dx dt is 8, and they want me to use all the information to find dy dt. And they give me this equation, x squared plus y squared equals 25. What do I need to do to that equation? Find the derivative, because if I'm going to use dx dt and dy dt to get to those two things, I have to take the derivative. So what's the derivative of x squared? 2x dx dt. What's the derivative of y squared?
2y
dy dt. And the derivative of 25 is 0. Phrase 154. After I take the derivative, then what do? Plug in everything they gave me. So 2 times x, which is 3, dx dt is 8, 2 times y, which is 4, dy dt is,
I'm finding that.
I'm finding that, and it's equal to 0. So now all I have to do is solve. So over here, 2 times 3 is 6, times 8 is 48. This gives me 8 dy dt, and it's equal to 0. Now what is it I'm trying to do?
Trying to find dy dt.
Trying to find dy dt, so what do you want to do next?
Subtract 48.
Subtract 48. And
Divide by 8.
so I get negative 48 over 8.
That's
Or negative 6. Yes, if you want to go to negative 6, that's fine. But I don't have to reduce that unless I'm dealing with what type of problem? Multiple choice problem. If it's not a multiple choice problem, leave it alone. Alright, now what does this tell me? What does dy dt equal to negative 48 over 8 tell me?
Change of y is negative 48 over
Alright, but what does that tell me about y?
8. Y is negative.
It's decreasing. Why does it tell me it's decreasing? Because dy dt is negative. Very good. Okay? So since dy dt is negative, that tells me that y is decreasing. Okay, just like on velocity. Velocity tells me if my position is increasing or decreasing, right? And how do I determine that? If velocity is positive, my function is increasing. If it's negative, decreasing. Same thing here. These rates tell you whether or not you're increasing or decreasing. So, them telling me that dx dt is equal to 8, what does that tell me about my x values?
They're increasing.
My x values are increasing. Okay? And let's draw a picture of this real quick.
Yay.
Okay, if I've got x squared plus y squared equals 25, we're dealing with a circle that has a radius of 5. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So I've got this circle. Okay? And we're interested at the point 3, 4. So at the point 3, 4, 1, 2, 3, and 4, approximately right there. Okay? Notice where I'm at. dx dt tells me that my x values are doing what? Increasing. So as I'm moving to the right, are my x values increasing?
Yes.
Yes, they are. Okay? This tells me that my y values are decreasing. As I continue to move to the right, are my y values decreasing? Yes, they are. So that's what these rates are telling me. Right, okay with that? Alright, let's look at the next one. The next one is number 16.
So at some point x will end up decreasing and y will.
Say it again.
So at some point x will change to decreasing, otherwise it's going to go backwards.
Right. Like once I get down here, well, we're still moving left to right. Over here. Here we go. Right here. If I'm at this point right here, what's dx dt going to be? It's going to be negative because as I'm moving to the right, I'm going to be negative. Okay. What about dy dt?
No, negative.
It's still negative because where am I going? I'm still going down. Okay. So what quadrant is dy dt going to be positive in?
2 and 4.
2 and 4. Because if I'm up here and moving to the right, my y values are increasing, my x values are also increasing. Okay. So really, actually, my x values are always increasing.
Because you're always going to the right.
I'm always going to the right, so my x values are always increasing. So dx dt is always positive. All right, let's move on to 16.
No,
All right, 16, it says, we're going to read this first sentence and we're going to stop and we're going to interpret what it is they just told me. 16 says, the radius r of a sphere is increasing at a rate of 3 inches per minute. Let me read it again. The radius of a sphere is increasing at a rate of 3 inches per minute.
The sphere is growing.
My sphere should be growing and my radius is increasing, okay? But what did they give me though? What are they telling me?
That your radius is increasing 3 inches per second.
My radius is increasing at 3 inches per minute. So how can I represent that if they're telling me my radius is increasing at a rate of 3 inches per minute?
3 inches over.
3 over 1.
Well, I agree with everybody should be able to see. And we're talking about 3 inches per minute, okay? But what is 3 inches per minute? What does that represent?
The rate of the radius. Rate of change of the radius.
Rate of change of the radius. So how do I identify that? What do I write down to represent that? There you go. We're going to call that dr over dt. Okay, to figure out what it is, it's always going to be over a time. So anytime you see a time, that means the bottom of it's got to be dt. Then to figure out what's on the top, you just got to figure out what is it that's changing. Okay, what they tell me was changing in this problem. The radius is changing, so to represent the radius, we're going to call it r. So it's the change in r over the change in time is what 3 inches per minute is. Now, it says the radius of the sphere is increasing. What does the word increasing tell me about dr dt? It's positive. It's got to be positive. Because if my radius is increasing, dr dt has to be positive. If it was telling me it was decreasing, what does dr dt have to be? It has to be negative. Because remember, dr dt tells me whether or not my radius is increasing or decreasing. All right, we're just going to do part A, and we're only going to do the r equals 9 because they want you to find it at 9, and then they want you to come back and find it as 36. But we're just going to do 9. So let's see what they want me to find. It says find the rate of change of the volume when r is 9 inches. So they're telling me when r is 9 inches. What is it they want me to find? The rate of change of what? The volume. So how do I represent that? dV over dt. dV over dt is what they want me to use. Okay? Now, just like on the last problem, we had x squared plus y squared equals 25, and that was what we took the derivative of. Okay? I need an equation that involves a radius and the volume. So the volume of a sphere is the equation I need, and this is, you do not have to have the volume of a sphere memorized. Okay, but the volume of a sphere is 4/3 pi r cubed. Okay, so the volume of a sphere is 4/3 pi r cubed. So now, what do I need to do to my formula? Nope.
Find the derivative.
Find the derivative. So what's the derivative of v? dv over dt. Okay, what is 4/3 in pi? What are they? They're coefficients. What happens to coefficients when I take the derivative? They stay there. So 4/3 in pi is going to stay here. And then I need the derivative of r cubed, which would be 3r squared, and don't forget dr over dt. Okay, so I'm going to go ahead and cancel these 3 since that's pretty easy to do. So I have dv over dt equals 4 pi r squared dr dt. Now what do we want to do after we take the derivative? Plug in all the information they give us. So what are we plugging 3 in for? dr over dt. Do I have something to plug in for r? 9. And dr dt is 3. Okay, so somebody give me 81 times 3 times 4.
We got 243,
Here, I got it.
that's
81 times 3 times 4. It gives me 972.
I was
Okay. Now, we haven't talked about units yet because that first problem we did didn't have units on it.
volume was
But, yes, what is volume? It's cubed. What are my units that need to be cubed in this problem?
Inches.
Inches. Yeah, my distance needs to be. So that would be cubed. And what is my unit of time? Minutes. Okay, you always take the unit of what's on the top over your time unit. That will always give you the correct one you want. Now, it says dVdt is 972 pi inches cubed per minute. What does that tell me about my volume? My volume is increasing because dVdt is positive.
You're increasing it 972.
Okay. Yes, my volume is increasing at a rate of 972 pi inches cubed per minute when my radius is 9 inches. Okay. Let's look at part B here. It says, explain why the rate of change of the volume of the sphere is not constant even though dr dt is constant. They're telling me dr dt is constant. Tell me why dv dt is not constant. You'll want to look right here. Why is dv dt not constant? Because, that's exactly. Say it again, Zach.
Radius is also a variable.
Okay, they told me this thing was constant, but is my radius constant? No, my radius is not constant. So since my radius is not constant, that means that dv dt is also not constant. It is changing. Okay, when my radius is getting bigger, my volume is obviously getting bigger. All right. Next one. How you guys doing? Come on. There we go. All right, next problem.
Cube.
Says the volume of a cube is decreasing at a rate of 48 cubic centimeters per minute. Stop right there and think about that. Don't blurt anything out. I want you to think about that and figure out in your head what it is they just gave you. The volume of a cube is decreasing at a rate of 48 cubic centimeters per minute. Okay, Garrett, do you know what they just gave me?
I gave you that you're decreasing at a rate of 48 cubic centimeters
All right.
per minute.
Yeah. As soon as I see this word rate, I should know I'm dealing with something over
D time.
what?
D time.
dt. Okay, as soon as I see that word rate, that means whatever they're giving me is something over dt. Okay, so Garrett, what is changing? If it's a rate, that means something's changing. What is it that's changing in that sentence? It says the volume of a cube is decreasing at a rate of 48 cubic centimeters per minute. What's changing?
The volume.
The volume. So what needs to be on top?
D of V.
dV, very good. See how we work through that? You see the word rate. What do I need to write down?
Something over DT.
Something over dt. And then what do I look for? What's changing? Whatever is changing needs to go on top. Okay? Now they said it's a volume of a cube is a decreasing at a rate of 48 cubic centimeters per minute. So I've got 48 cubic centimeters would be centimeters cubed per minute. And that should make sense because if it's dV, what should my units be?
Volume.
Cubed. It should be something cubed and dt should be in my time. Okay? But there's one more thing I need to identify. What is that?
The positive.
Right, I need to know, is my rate positive or is my rate negative?
Negative.
It's negative. Why is it negative?
It's decreasing.
Because it says decreasing. If volume is decreasing, that means dV dt has to be negative. And that's the thought process of being able to take in some information they give you. Alright, then it says, determine how fast an edge is changing at the instant the volume is 1,000 cubic centimeters. Is 1,000 cubic centimeters a rate?
No,
Why not?
because
It never
It's
said
not-
rate
it's
in the
not a-
quality.
They didn't say rate,
Over time.
and my units is not over time. So what is 1,000 cubic centimeters?
it's
It's volume. It's yes. It's volume. All right. That's volume. Now, what is it they want me to find?
as or side, edge,
Velocity.
the rate of change of an edge.
The rate of change of an edge is what they want me to
Per
find.
meter.
Because it says how fast is the edge changing. Okay. When they want to know if something's changing, they want to know what's the rate of it. Okay. So to determine that out, or to determine that, I need to find an equation that has both rates inside of it. Just like on the last one, it was the volume of a sphere.
Cube.
What equation do I need here?
Volume of cube.
The volume of a cube. What's the volume formula of a cube?
As cube.
Yes, because a cube, the volume of a cube is S cubed, because I've got
Cube.
all my sides are the same and it's a cube, so I'm going to do S cubed.
Cube.
All right, now what do I need to do to B equals S cubed?
Plug in.
No,
No, it defines derivative.
you
Yeah.
have to find the derivative. Find the derivative before you plug in.
I have now.
So that gives me 3S squared
ds and dt.
ds over dt. Don't forget the ds over dt. Okay, that's going to cause you problems if you forget. Anytime I take the derivative of a variable, I've got to have it over dt. All right, now what do I do? I plug in. What do I plug in for dv dt?
1,000.
Whoa. Negative 48. I need something to plug in for s, and ds dt is what I'm looking for.
Well, you know that if you volume at 1,000, each side has to be 1,000 cube root 1,000.
All right, and here's what I want you to understand. You need to always take the derivative, and then you plug in. If you don't have everything you need to plug in, you go back to the original equation to find it. Okay? I need an s. I don't have an s, so I need to go back to the original equation and find it. And they'll usually give you another piece like they did here. They told me volume is 1,000. So I do 1,000 equals s cubed. I take the cube root, and that tells me s is 10. So then I can stick 10 in here. So I have negative 48 equals 10 squared is times 3, 300. All right, then what? I divide, I get negative 48 over 300. And that gives me ds dt. Now we need to talk about the units.
Centimeters.
ds is a side. What's my unit of a side?
Distance.
It would be a distance, so what's my distance in this problem? Centimeters. And then what's always on bottom? My time, and what's my time in this case? Minutes. So what does negative 48 over 300 centimeters per minute tell me?
That your sides are decreasing.
My sides are decreasing. That's what dsdt tells me. If dsdt is negative 48 over 300 centimeters per minute, that tells me my sides are decreasing. And that should make sense because what was my volume doing?
Decreasing.
If my volume's decreasing, what does my sides have to be doing?
Decreasing.
They've also got to be decreasing. Okay, so what's our, if we're dealing with related rates, what should be our approach?
Find derivative
Before that,
right after
Write down the problem.
I need to write down what the problem gives me. It's usually going to give me a rate, and it's usually going to give me something else. Okay, and it's also going to tell me what rate it wants me to find. So write down the rate it gives you, write down the rate it wants you to find, and write down the other information it gives you. Okay, so that's the first step. What's the next step I want to do?
Equation.
I need an equation to start with. Okay, it's usually going to be a volume or some equation like surface area or something like that. Okay, once I have my equation, then what do I want to do?
Find derivative.
I take the derivative of it. Okay, once I take the derivative, what do I want to do?
Don't forget
Don't forget the DTs on everything you take the derivative of, and once I have the derivative, then what? I plug in the information they give me. What if I don't have anything?
Go to the original equation.
Go back to the original with the other information they give you, define what you need. Plug it in and solve for whatever rate there is. That's all there is to it. Got it? Good. We'll give you 4 problems to work.
Well, for our homework or just work?
Homework. So I'm gonna have you write it down, we'll take a breath, and then we'll get on Thursday's assignment. So on page 154, 3, 13, 17, and 19. Let me see if there is anything you need. On 13 you need, read through 13 real quick and tell me what equation we need to 13.
Area of the circle.
We need area of a circle, so what's area of a circle? Pi r squared, so you should know that. 17 says the volume of a spherical balloon, so what formula do I need?
The volume of a sphere.
Volume of a sphere, what was that?
4/3
4/3 pi r cubed, make sure you have that written down. And 19 says determine how fast the surface area is changing, so what do I need there?
surface area of a cube.
Surface area of a cube. What's the surface area of a cube?
Six S.
6s squared would be the surface area formula you need for 19. So on 13, pi r squared is your formula. On 17, 4/3 pi r cubed is your formula. And on 19, 6s squared is your formula.
Yeah, you can tell I took this as a subscript, so